let's try and understand this question here. So civil engineers design bridges to span over expressway. The diagram shows represents a bridge over an expressway PS. So we are told that PQ and PSR are parallel to the y-axis. So I'm just going to quickly draw this out. And that the arc of the bridge QR yada yada is followed by this parametric equation. So we understand that. With A is a positive constant, the unit x and y are in meters. At the point Q, theta is beta. So this is theta is beta. So these two lengths are the same height, right? QP equals to SR. So just label this. Now usually when it says parameter, I will encourage students to just write theta equals to beta at this point. And this one here, it corresponds to theta equals to 2 pi minus beta. But before we start, do you know what is parametric equation? Parametric equation is, it means that you have this parameter, okay? So, okay, let's say this is the equation that I have. This equation that we have, okay? So what we do is, let's say we sub 3 into this equation. So we sub, when P is 3, when theta is 3, we will get this point here. Okay, then after that we substitute 3.1, then you get another point. Get it? So any point that we put in, right, we just keep iterating it. We just put one point inside, then we just put one point and put it again, alright? So when we trace everything out, right, I think you cannot really see this side here. When we trace everything out, we will get the parameter, okay? But that's why the parametric equation is important, because you need to always define where you are drawing, okay? The parameter is important because it's the invisible force behind the curve. It put into the equation, it just tells what the equation should behave like. So every point would have a different parameter. Every point have a housing address. It's just like your vector line equation, which, if you remember, I believe all of you remember, your A plus lambda B, right? Your vector line equation, A plus lambda B D, right? This is a housing address. That's why this is called vector parametric line equation. The lambda is a parameter. You just put it there. That's a housing address. You specify it. So whenever you do parametric equation, it's good to just label theta is beta. Theta equals to pi minus beta, because that corresponds to the housing address. Yes. Okay, so now find in terms of distance of PS should be quite straightforward, because what we need is actually just to find the coordinate of x, right? XP here, and then the XS, and then just minus them. This one here, the distance here, we just need to minus them off, right? So XR, so let's say XP is theta. When theta goes to beta, XP equals to the x coordinate at Q is A beta minus sine beta 2 pi minus beta XR. So beta is A is 1. And then this, okay, we can simplify this. So this one here, this is beta. You can either remember that sine 2 pi minus theta is equals to negative sine theta. What? 2 pi minus theta. Negative sine theta. Okay? Or if you don't remember this, it's okay. You can just expand it. Okay, so you just expand it like using sine A minus B. This is A. Okay, this will be distance PS this is XR, is XR minus XS XQ. There you go. If you're confused, the area that you require is this area, shaded region representing the area, right? Now what you need to know is there's no such thing as parametric equation integral. What you just write in what you do in secondary school, you will do this required area. Actually, it's just you know that this is from xq to xr y dx. Am I right? This part here, now what you need, your whole goal in parametric, right, is to change this to in terms of a function of d theta. We know that, and d theta. Now every year, millions of marks students will lose it at this juncture here. This juncture is very important, very important, very important, very important. Remember this, very important, When this is dx, this is x. All these are x value. So when you change your definite integral, remember to change to parameter. Remember that, This one every year students will die one. Will die one. Just make sure you change to in terms of theta, theta. Okay? So what we're gonna do is, let's do it slowly. This part here. This will be y. Y is a 1 minus cosine, right? So a 1 minus cosine theta. Then dx d theta, because x is we need to differentiate our x a d theta minus sine theta here. So dx d theta is a1 minus, differentiate sine is cosine theta. So this one, remember, you treat this as entity. Of course, this is dx equals to a1 minus cosine theta d theta. Your school will say, cannot write this. Please erase it out after usage. Only one time disposable, okay? Use it once, then just throw it away. So then once you're done already, you'll be a1 minus cosine theta d theta. Okay, remember this one. Remember this one. This one important. This one important, This part is important. This is how you see it. When x is equal to xq, the corresponding point for q is this parameter. Do you see that? This is invisible force here. So xq will correspond to beta. xq is beta is here. Maybe I should use a red color so that you remember forever. So this is beta, theta. Then this one over on top will be 2 pi minus beta. So this is 2 pi. Okay, here. Here will be, make a square outside. So a square. Beta, 2 pi minus beta. This will be 1 minus cosine theta square d theta. Pretty okay. Then expand it. Remember, for trigo integration, you only have that few expression you can integrate. Sine square theta. This one here, what you need to do is you need to down the power, because you can only integrate any of the 8 expression, right? So remember, any of these 8 here. So you by any means necessary change to any of these 8, And power of 2, very conveniently, we know is power of 2, right? We know that cosine 2a is equals to 2 cosine square a minus 1. The beautiful thing about this equation here is you can change from a square to a power of 1. Oh, so remember your cosine 2a is beautiful because it sort of mess up our trigo life. So this one here, yeah, cosine 2a plus 1 over 2. Good job. My whole goal is to change to any of the 8 or using cancelling method. But this case here, I can just any of the 8 will be do. Cosine theta plus half cosine 2 theta plus half d theta. Then I'll just do it slowly. Okay, maybe not. Can I just integrate? I think I'll just integrate. Over 2 theta. To here to here. But what I'm going to do is, because there's a half in front, I'm going to just factorize a half out. That will be here. Half 3 theta. Then I minus off. So by what we learned in secondary school, we know that okay, there you go. You can use the same thing. You can use the formula. Okay, if you want to. But I just use the identity because if I were to rewrite it, my hand is going to drop off really. So this is like okay. Okay. You like. So for this one here, you are told that the area is this one. Find the value of beta. So I'm just going to equate this to the area. That's pretty okay. So part C, 7.8159A Okay, this one here. Please use calculator to solve it. So we just key in. This is y1 and y2. $7.8159. Then this will be half 2 pi. 6 pi. Okay. Graph it. Okay, there you go. That's my solution there. 1.90. Oh, nice. The width of the expressway is actually 50 meters. So PS is 50. This is 50. Okay, so this is expressway. Okay, so meaning okay, this is expressway. So this is 50 meters. 50 meters. Great. Okay. Then find the greater and least height of the arc QR above the express. Oh, meaning this will be the greatest height, right? Sorry, this is the least height, right? And this is the highest, the tallest height. Is it the least? This is the greatest. Isn't it? Is it a typo there? Should be a greatest, right? Now, so you are given 50 meters PS. PS is PS is what? PS is where's PS? PS is this one. Alright. So this is PS. I'm gonna write this down. Distance PS. So part D. 50. Okay, maybe I should use a new blank piece of paper. PS is equals to 50. So I take from previous part, which is 2a pi minus beta plus sine beta equals to 50, and then beta is equals to 1.90 sine okay, there you go. So this one will be a equals to 11.426. Now, so we have a already. Take note, from this diagram here, the least height, the height is of course y, right? The y least, right, will be y when theta equals to beta. I know issue that. Because you see this is invisible force. That will be theta is beta here. Yes. So in other words, the least height is y when theta is beta. From the diagram, you can see that. Then what is my y? Wait, I need to see my question here. Y will be a 1 minus cosine beta then. And basically I have 11.426 1 minus cosine 1.90 radian. This would be 15.1 meters. Okay, maximum height, there are actually two ways to do it. You can either dy dx equals to 0, the top height there, but that will be too troublesome because maximum height here, we don't have a parameter here, but what we know is y is equals to a1 minus cosine theta, right? So if y max happens when cosine theta is -1. Right? Y max. You can look at this formula here. So y max. Okay, so this one is y is equals to a1 minus cosine theta, right? You know that cosine theta oscillates from 1 to -1. Okay, so this is like a secondary school question altogether. So y max would happen when this is minimum lah, because this is 1 minus something ma. So a 1 minus -1. So this is 2a. It will be 2 times, what's my a? 11.426. This will be so this is the greatest height.